Welcome to Module 4 of the Six Sigma Institute's Lean Six Sigma Certification Curriculum, which follows both the Council for Six Sigma Certification and the International Association for Six Sigma Certification Bodies of Knowledge. A full copy of the Council for Six Sigma Certification's Book of Knowledge can be downloaded from the course description section for free. In this module, we will be discussing the basic concepts of lean. This module will take approximately 50 minutes to complete. At the end of this module, there will be a 5-question quiz on the topics discussed, which you can complete on your own time. You will also find several Six Sigma tools that you can download, including a downtime waste checklist and a 5S checklist, both of which are Excel files. Lean Six Sigma incorporates both Six Sigma and Lean into a popular approach that achieves greater results by improving a process so that both defects and waste are eliminated. In this section, we will discuss the potential for wasteful activities within a process. According to Taiichi Ohno, the man considered to be the father of Toyota production system, there were 7 traditional forms of waste or Muda. But today we commonly recognize 8 forms of wasteful activities which are identified using the acronym DOWNTIME. We will identify these forms of waste so you can seek them out and eliminate them from any process. Eliminating waste is one of the underlying goals of Six Sigma. You might imagine the waste of uneaten food that gets thrown away regularly at hotels. But we're actually talking about a much broader concept of the word waste. It is important to eliminate waste in order to spend more time and resources on providing value to the customer. The more an organization can reduce waste, the better. The acronym DOWNTIME is an easy way to remember the 8 wastes of defects, overproduction, waiting, non-utilized talent, transportation, inventory, motion, and extra processing. Several of these forms of waste sound repetitious, such as the waste of overproduction and inventory or the waste of transportation and motion. This is why we will need to define them in greater detail. Defects are mistakes that require additional time, resources, and money to fix. In a manufacturing process, a defect might involve a defective part that has to be remade. Defects can be caused as a result of poor quality controls, incorrectly repaired equipment, bad documentation, a lack of standards for a given process, weak or even missing processes, and a misunderstanding of the customer's needs. Damages may also occur after production as a result of uncontrolled inventory levels. Completely eradicating any form of waste is impossible, but defects can certainly be limited by the application of standardized work plans, more stringent quality controls at all levels, a full understanding of work requirements and customer needs, and simple job aids such as checklists. Overproduction is when you manufacture based on projections rather than actual demands. In some organizations, workers just blindly keep producing even when those who receive their output are either not ready for it or do not even need it. These customers can be external end users of the product or even another process within the organization. This is a big flaw as it can tie up significant working capital. It is especially common in manufacturing, but can occur in any workplace situation where there is a bottleneck. Overproduction may occur as a result of what is known as just-in-case production. Producing to a forecasted need, engineering changes, poorly applied automation, or just plainly unclear customer needs. The solution to overproduction is to establish a reasonable workflow for the benefit of the customer. Be sure that there are well-established procedures in place for every process in your organization and if necessary, implement new processes to keep work from backing up behind particular bottlenecks within the organization. Waiting occurs whenever work has to stop for some reason. Maybe the next person in line is overwhelmed. Maybe some pieces of equipment are broken. Maybe it is because you are waiting for an approval from a supervisor or for the delivery of materials to a construction site. Or maybe it is because you have run out of something and it needs to be replaced. Common causes of waiting are as a result of unbalanced workload, unplanned downtime, insufficient staffing, or even work absences. It may also be the result of poor process quality or poor communication. Whatever the cause, some workers have to wait for a bottleneck to be cleared. One way to address this is the need to provide adequate staffing to handle the workload at the bottlenecks, which some managers may target as a source of monetary waste. Not utilizing talent is the eighth form of waste that was not part of the seven traditional forms of Muda, but it has been increasingly seen within businesses today. Not or even underutilizing people's talents, skills, and knowledge can have a detrimental effect on an organization. Companies can experience great benefits when recognizing the value of skills and improvement ideas from all levels of the business, and can suffer when not effectively engaging in the process. This form of waste is commonly caused by assigning staff to wrong tasks, poor communication, mismanagement, a lack of teamwork, and even insufficient training. These causes can also result in a lack of employee engagement, which can hamstring any organization's productivity. Key solutions include empowering your employees, stop micromanaging, and of course, increase training. The waste of transportation is caused by moving things around. It is different from the waste of motion, which we will discuss later. It is less of a problem in a business office than in a manufacturing plant, since most of what white collar workers transport can be sent by email. Too much transportation tends to increase costs, waste time, increases the likelihood of product damage and deterioration, and can result in poor communication. The waste of transportation is generally a result of poor plant or office layout, a misaligned process flow, badly designed systems, or even unnecessary or excessive steps in the process. Limiting transportation waste can be easily addressed by common sense efforts such as simplifying processes, repairing physical layouts, handling products less often, and making distance between steps as short as possible. The waste of inventory excess can be the result of overproduction. It is itself a separate form of wasteful activity within an organization. It occurs when there is a supply that exceeds customer demand. Beyond overproduction and maintaining a supply buffer, inventory excess can occur as a result of poor monitoring systems, mismatched speeds between production lines, unreliable suppliers, and even a misunderstanding of the needs of the customers. As more organizations convert to a just in time management methodology, the issues surrounding inventory excess become less important, but can still occur when products leaving a faster process enter a slower process, which causes a bottleneck in the overall production system. Motion waste is any excess movement, whether by employees or machines, that does not add value to the product, service, or process. This is different from the waste of transportation, which is a result of having to unnecessarily move people, products, or equipment. Poor process design and controls and poor workstation layout are some of the most common causes of motion waste within an organization. But shared tools or even isolated workers can result in motion waste as well. The solution is to rearrange layouts to decrease the distance between stations and make it easier to reach things that are often used. Excess processing is when we add something to a product that holds no value to the customer. This form of waste often occurs due to the creation of multiple versions of the same task, such as the infamous TPS reports in the movie Office Space. It can also occur when you process more than is required, or when it is a long winded, poorly designed process, such as the production of excessive reports, the requirement for multiple signatures, or the need to re enter and duplicate data. All of these unnecessarily increase your costs, time, and resources. You must first examine and map your organization to analyze the processes in order to fix them. Standardized processes empower employees and eliminate unnecessary documentation, sign off processes, and meetings. While Toyota originally defined 7 common Muda, even Taiichi Ono agreed that other type of wastes exist. In this section, we are going to take a quick look at 2 other common forms of waste within an organization that do not fit into the 7 traditional forms of Muda. These forms of wasteful activity include the ignoring of other people's ideas and the failure to invest available capital into improving the organization. The Muda of ideas occurs when the thoughts and ideas of people are discounted, not sought out, or misappropriated in a way that doesn't make sense. Leadership and project teams can often overlook subject matter experts who have detailed insight into a process and, as such, could offer firsthand knowledge and ideas. The result could be the design of a process that works great in theory, but falls flat once it is instituted. One reason waste of ideas is such a concern for organizations is that people themselves rarely come forward with thoughts. Staff members might think they don't have anything real to contribute, might feel like their ideas won't be heard, or could be anxious about looking silly or ignorant. By fostering all ideas in a safe environment, teams can foster valuable ideas and avoid waste of ideas. Saving for a rainy day is smart, but banking cash when there are profits to gain isn't always the right decision. The Muda of capital or cash occurs when leadership decides not to invest in upgrades or improvements that would otherwise create additional cash flows for the organization. This type of waste is very similar to waiting, except the cash itself is waiting, often for a time when leadership feels safe enough to spend it. Six Sigma helps to reduce the Muda of cash because statistical analysis helps point leaders to decisions that involve the least risk or most gain. No business decision is 100% guaranteed, but Six Sigma helps leaders hedge bets by using statistical data in decision making processes so they don't sit on cash or capital that could be used to drive gains in efficiency, production, and of course, profit. All Muda is waste that fails to add value to a product or process and can be divided into 2 types. In the previous section, we covered the 8 most common forms of Muda, as well as the Muda of ideas and capital. But all Muda can be broken down into 2 types, and in this section we will discuss those 2 types of Muda and what you should do with them when you discover them in a process. Type 1 Muda are non-value added tasks that might actually be essential or required by circumstance. Inspection of products during a process might be required if the process is known to produce defects. Organizations don't want defects to reach the customer, so they put quality controls in place. The act of the inspection and the time and the expense it adds to the process are all Muda. However, an organization cannot remove that waste until it addresses the cause of the defects within the process. Sometimes, auxiliary processes within an organization are type 1 Muda. For example, the external end customer doesn't receive direct value from human resources processes within an organization. At the same time, if employees don't receive paychecks or support regarding benefits, then they aren't likely to continue performing work. Those processes are then essential to the organization, but instead of removing the Muda completely, teams might look for ways to make essential Muda as efficient and cost effective as possible. Type 2 Muda are non-value added tasks that are not essential and can be immediately removed from a process. For example, if a product is carried to and from several workstations while it is being completed, it is likely a type 2 muda of conveyance. By rearranging the workflow, teams might be able to reduce the muda by a substantial amount without making any actual changes to how the product is put together. In Lean, it is our goal to remove all forms of wasteful activities from a process, but in practice, this is not always possible because we can only remove type 2 muda. This concept is very similar to the paradox we face in Six Sigma, where we want to remove all forms of variation in a process, but in practice, we can only effectively eliminate special cause variations. 5S is a Japanese lean approach to organizing a workspace, so that by making a process more efficient and effective, it will become easier to identify and expunge muda. In this section, we are going to discuss a popular lean tool that can be used in any organization to reduce waste and improve the overall efficiency of any process. We are going to talk about 5S, namely sort, straighten, shine, standardize, and sustain. It is an approach to organizing workspace so that by making a process more effective and efficient, it will become easier to identify and expunge muda. 5S relies on visual cues and a clean work area to enhance efficiencies, reduce accidents, and standardize workflows in order to reduce defects. During the sort phase, all items or materials in a workspace are reviewed, removing unneeded items and keeping necessary resources. Consider the copy room in an office. Over the years, supplies, tools, and machinery have piled up. When going through the room, teams might decide that the stapler and scotch tape stay. People still need to staple pages or access tape. The old paper cutter isn't necessary for the team since no one ever performs paper cutting duties. However, someone notes that the team in shipping and warehousing has to manually cut pages down sometimes. So, the paper cutter is relocated to that department. The team decides to toss a bin of miscellaneous loose paper and an old fax machine because a new copy machine includes fax capabilities. By eliminating obstacles and unnecessary items, costs, time, and employee frustration are also removed. The sort step lets you take inventory of an area, discover unused or wasteful resources, and make room for reorganization. Sort can also be applied with computerized processes. Once excess is removed from the work area, teams must provide a streamlined and easy to use location for everything necessary to the workspace. During the straighten phase, every item, tool, or material is given a home. To facilitate ongoing organization, the location of resources should be labeled clearly. The idea is to create a workspace that anyone could use. If someone from another area comes to your copy room, it should only take a few seconds to locate the right size paper. Employees in a factory should be able to move from one station to another station and find equipment and tools with ease. The goal is to provide the visual controls that allow for common sense operation. Labeling a shelf for letter size paper, arranging sockets in size order in a drawer labeled sockets, or parking the forklift in a marked area of a factory floor when not in use are all good examples. Labeling the stapler with a label maker is an example of things going beyond common sense. You don't need to label items that most people in the workplace would recognize on site. The third phase in the 5S methodology is targeted to keep the workplace clean and neat. The goal is to shine the workplace by cleaning it, maintaining equipment, and returning items to the proper place after use. It is not just something that occurs at the end of shift or when the production is complete. Rather, it is something that must be maintained throughout the day in order to minimize potential issues that can be caused by clutter. In a computerized environment, the shine phase can be accomplished by naming files in a manner that makes them easy to locate, keeping folder structures intact, and deleting or archiving files that are no longer necessary. Shine can be applied to any environment, regardless of whether it is physical or digital. The standardized phase is used to maintain the progress achieved in all previous phases. By keeping high standards of orderliness in place, the benefit of 5S methodology can be long term. The stress and speed of a daily workday can make it hard to keep up with the 5S standards. If everyone is committed to working together, the benefits can be ongoing. It is during this phase that we can start integrating the 5S procedures developed into the standard operating procedures for the organization. We may even revisit previous phases in order to add additional visual cues like infographics to remind employees of these procedures. 5S, like much of Lean Six Sigma, is a continuous improvement process that always strives for perfection. 5S only works if everyone on the team or within the organization commits to the process. Employees must follow the rules that are set up for standardizing and sustaining the organization. Otherwise, the team enters a cycle of cleaning up after a period of failing to keep up with the standards of 5S. The ultimate goal of sustain is a change in the organization's culture. It is only through a complete cultural change within the business that we will be able to successfully maintain the work that we have accomplished through the 5S methodology. There are countless benefits to using the 5S methodology in any organization, and all of them are good. They all translate to increased profits and customer satisfaction, which are the overall goals of Lean Six Sigma. The most common benefit of implementing 5S is the reduced risk of accidents and safety issues, which helps to increase compliance with regulations from organizations such as OSHA. Once initiated, it creates a stable foundation that makes additional improvements easier to implement. Because it makes an organization more efficient, it becomes easier to identify and even eliminate wasteful activities within the organization or process. And all of this results in an improved output quality, whether it is to the external customer or to another process within the organization. The goal of just-in-time manufacturing was to produce an output just in time or as needed by the customer. It is a key tenet in the pull manufacturing system. In this section, we will discuss the just-in-time management principles, which includes manufacturing. We will take a deeper look at how it helps eliminate waste through simplifying a process with an inventory pull system that is team-oriented and requires a well-organized production plan, which takes into consideration important factors like the variations in the production times between different processing units. Just-in-time manufacturing showcases the epitome of lean manufacturing, as it exists with very little waste. The method was born in post-World War II Japan, where resources were limited. The lack of cash, inventory space, and natural resources forced Japan to seek leaner methods of production. This practice is now the legacy of one of Japan's biggest manufacturers, Toyota. It requires all stages of manufacturing to be run without hiccups. The steady rate of production under just-in-time manufacturing involves no machine breakdowns, no human errors, and a highly reliable supplier that can deliver parts on demand. In order to seamlessly practice just-in-time, producers must forecast future demands accurately and in a timely manner. Just-in-time cannot exist when there is too much waste within a process, as it is more sensitive to variations than batch processing. While most organizations up until the 1990s operated using a push system where production was based on a forecasted future demand and a warehousing of excess inventory, more and more companies have been implementing just-in-time manufacturing because its pull system is more efficient and tends to result in higher quality outputs. In practice, every process begins with a request. A request comes from a customer, whether internal or external. who orders the product or service. The request initiates a pull through the production system whereby each point sends a request to the point before it, ordering the supplies it needs to complete that request. In just in time manufacturing, nothing is produced unless there is a request, unless there is a specific demand for it. Because every production point within an organization operates at a different speed, teamwork is crucial to the implementation of just in time manufacturing. Each point of the system needs to be timed accordingly so as to prevent any possible bottlenecks in the system, as the opportunities for error are increasingly magnified in a pull system. All teams within the system must be in sync with one another too. As a result, they become more efficient, and the level of overall quality produced by all of the processes increases exponentially. When it is all said and done, despite the amount of work and planning involved with just-in-time manufacturing implementation, the overall system is simpler once implementation is complete. This is because there is no batching of products and no need to guess or otherwise forecast future demands, then have a large enough warehouse to store all of that excess inventory. The increased quality outputs results in a reduction of wasted or spoiled products, and the space that is needed for production is greatly reduced. A lower production footprint requires less space than a push system, and therefore there is a reduction in the overall operating expenses for companies that implement just-in-time manufacturing. In a just-in-time manufacturing system, the higher precision of the process means that defects are easily identified. Because of the requirement to sync the different processing points within an organization, teams work closer and are able to monitor each other's performance. Teams that have been trained in lean methodologies can quickly identify opportunities and even conduct spot Kaizen events in order to fix any issues that pop up. All in all, as a result of the increased visibility, the overall process is easier to monitor and can be centralized, making it easier for management and leadership to access it.